Oh, it doesn't say I'm live. Why does it always start unlisted? That's annoying. Where do I change that? Public. Okay. Cool. I think this is working. Awesome. Alright, let's make sure the stream is actually up. Looks like it's not unlisted, so it should be live. And we should be good. People will probably funnel in the next 5 minutes. I'm going to double check my phone. Okay, looks like I'm live. That is awesome. I get an email when it says I go live. Hey, got that. We're good to go. Awesome. So I guess I'll put up my starting screen, right? It's ugly. It looks so ugly. It's so ugly. But whatever. Okay. Let's see where we are. I'll give it like a minute for people to join. Oh. Yeah. Oh my god. Oh my god. I'm fighting off a headache right now. I'm dosed up on ibuprofen, so we'll see how many I can get done. Today was a weird day. I don't even know if anyone's watching, but today was a very weird day. Just slept most of the day. Took off of work. Just felt not fantastic. Took a couple naps, but whatever. Like, I had to get stuff done, but I was also fighting off a headache, and then when I got home, I just crashed. And it's whatever. But I'm up now, feeling better. Hopefully that headache's just behind me. Nothing a lot of water and ibuprofen can't fix, so that's where we are. Alright, let me test the chat, make sure this is working. Test message. Hey, looks to work. Or looks to work. Looks like it's working. Awesome. Let's see. Oh yeah, what's up? People are already in the chat. It's awesome. I'll never have the courage to stream while solving an AOC problem. Don't say never. Yeah, no, I don't even know if it's a thing of courage. It's just like, just do it. It's fun. I know that eventually I'm going to hit a puzzle where I just won't be able to solve it. But on my stream, you will see me give it my all. And at the end of the day, like, I'm proud of that. So, yeah. But yeah, I understand the feeling, though. It can be a little bit nerve-wracking. Like, but I enjoy it. I like going into these puzzles blind and being like, hey, let's see where my problem solving takes me. And if I can't do it, then I can't do it. But I tried. All right, let's get started. I'll pop open the website. Here we go. We got Advent of Code. As you can see, we are 5 days in. We are going to start day 6 today. Let's do it. Day 6. Guard Gallivant. The historians use their fancy device again, this time to whisk you all the way to the North Pole prototype suit manufacturing lab in the year 1518. It turns out that having direct access to history is very convenient for a group of historians. I would imagine. You still have to be careful of time paradoxes, and so it will be important to avoid anyone from 1518 while the historians search for the chief. Unfortunately, a single guard is patrolling this part of the lab. Maybe you can work out where the guard will go ahead of time so that the historians can search safely. Make sense? You start by making a map, your puzzle input of the situation. For example, okay, we have a lot of periods, some pound signs, and then this little character. The map shows the current position of the guard with that character, okay? Guard is currently facing up. Oh, I see, from the perspective of the map. Any obstructions, crates, desks, alchemical reactors, etc. are shown as a pound sign. Lab guards in 1518 follow a very strict patrol protocol which involves repeatedly following these steps. This is very convenient for us. If there is something directly in front of you, turn right 90 degrees, Cool. Otherwise, take a step forward. Okay, this all seems easy so far. Following the above protocol, the guard moves up several times until she reaches an obstacle, in this case a pile of failed suit prototypes. Okay, so she starts down here somewhere and she works her way all the way up and she hits this wall. So she stops. Because there is now an obstacle in front of the guard, she turns right before continuing straight in her new facing direction. That makes sense. She was here and then she went to the right. Cool. Reaching another obstacle, a spool of several very long polymers, she turns right again and continues downward. Cool, this makes sense, so she goes here. This process continues for a while, but the guard eventually leaves the mapped area after walking past a tank of universal solvent. Okay, cute. By predicting the guard's route, you can determine which specific positions in the lab will be in the patrol path, including the guard's starting position. The positions visited by the guard before leaving the area are marked with an X. Okay, so she started down here, worked her way up, down, da-da-da. Yeah, so you can mark all of them with an X. In this example, the guard will visit 41 distinct positions on your map. Predict the path of the guard. How many distinct positions will the guard visit before leaving the mapped area? Cool. Okay. I'm going to go ahead and say something I might regret, but I think this might be somewhat easy. I have some experience doing like 2D game stuff with like grids like this and map layouts. So yeah, I think we can do this. So let's go ahead and get the example input. I'm going to go ahead and put this into my terminal. Let's pop open the terminal. Cool. So let's double check where we are. Cool. We are in day 6. This is perfect. Example input.text. Put that here. Awesome. And then I'm going to go over and grab the real input. And this is just for me. So I'm going to turn off my screen share for that. Vim real input.text. Oh, that's a lot. I love seeing that. Okay, and the share is back on. So what we have to do is we have to read in this data, create some sort of 2D grid, and we're going to go through it, and we're going to be this person who's facing upwards. Now my question is, in the real input, will she also be facing up, or could she be facing a different direction? I'm going to look for this real quick by just looking for this character in my real input. Yes, okay, so she will be facing upwards there. So the guard is facing up to begin with. That's nice. I don't have to worry about like a greater than, less than, and a down facing arrow. Okay, cool. We are good. Let's take a break. Let's look at chat. Yes. A is easy. B is a bit hard. Couldn't find a brute force solution. Okay, cool. Yeah, we'll see. I'm excited to see what this looks like. So we'll call this part 1. I'm not going to try and be clever with the names anymore. We are just going to name these scripts exactly what they are. So we have part 1. That is all we will call it. Let's vim that file. Let's take a look at what we got here. And we are going to read in this puzzle, and we want to read it into a 2-dimensional array. We don't have 2-dimensional arrays, so we have to fake it with an associative array. And we will just call it grid. So while read -r line do done echo line. This should just read the file line by line. So let's go ahead and test this by reading it from example input. And we get that. That's exactly what we wanted. We are reading the file line by line. So now that we are reading it line by line, we also need to read it character by character. So let's call this, instead of line, we will call this a row. And we will make it an array. Perfect. That makes sense. We will also need to calculate the the width and the height. So let's do that here. Let's say width equals 0, height equals 0. And then we will calculate it. So let's do this one thing at a time. Let's worry about width and height later. Let's just save these to the grid. So we are reading through the row, and our current row is, how should we keep track of this? We should probably have a y coordinate and a, yeah, let's trash these for now. Let's have a y coordinate and an x coordinate, right? Okay. So every time we read a row, when we're done reading that row, we will increment the y coordinate because we will move down to the next row. And then we will do a for x equals 0, x less than width x plus plus, Cool. Now we have to actually calculate the width. So let's do width equals the length of the row. This should never change. Every row should have the same width. So we can just technically do it each iteration. It's kind of redundant, but that's okay here. So we'll get the length of the row. So now we have a width. So what do we have here? We have the width. We have this y++. And then when we get to the bottom, we can say height equals y. Okay, now we will have the height and the width when we are done with this. We don't need this. Okay, so in here, we can say, let's just echo this out. Let's do x comma y equals whatever character is there. And the character C will be what is at row at spot X. It's a little bit confusing, but when we print this out, I think this will be easier to understand. So we'll say at coordinate X and Y, it equals to character. Not even close to right. What did we do wrong here? I'm going to be just indexing something slightly wrong here, but that's okay. Let's do echo width equals width, and let's see what we got going on here. Okay, so we think it's a width of 1. Why is that? Oh, we've run into this before. It's because I'm trying to break them on something in the IFS, and there actually is nothing to break them on. So instead of reading them into an array, we'll just keep reading them into a string. That's fine, but we will just index the string at that spot. And the way we do that is we don't access it like an array. We access it at spot X, and we want one character. So we're going to do a substring notation here. So row stopped being an array. Row is a string, but that's okay because we can get the length of the string, and that's the width, and then we can get the character there. So if this all worked out, then it's still broken. Awesome. Okay. Let's figure out why we are broken. Let's just do this too. Width equals width. Height equals height. And let's make sure we know what's going on here. Width equals 1 and height equals 10. Okay, well, that's incorrect. Oh, because I'm using array notation there. That doesn't make sense. This notation allows you to get the length of a string, not an array. So, okay, that looks better. Width of 10, height of 10. Is that correct? 1, 2, okay, we have 10 lines. 1, 2, 3, 4, 5. 1, 2, 3. Okay, it's 10 by 10. So that's good. That is correct. Now we will just do some spot checking here. So if we look at coordinate 4, 6, that's X, Y, we should find the guard. So if we're on the X coordinate, 1, 2, 3, 4, so this is 4 over from the left, and we move down 6, we should get here. Is that right? That is right. Oh, you know why? Because it's at a 0 index, and so it's the 7th line is where array spot 6 would be, because it goes to 9 and not 10. Okay. This actually makes sense. We are getting somewhere, which is crazy. That's awesome. So what we should do is we should find out the X and Y coordinate of the guard while we're doing this. While we're going through and we're calculating all this, we should figure out where the guard currently is too. So what we'll do is we'll do guard X equals -1, guard Y equals -1, and then if C equals this character, which is the guard character, then we know that we have found the guard. And then we will do guard X equals X, guard Y equals Y. If we wanted to be pedantic here, we could do some checks. We could make sure that these variables are -1 before we set them. We could make sure that down here that we definitely did find the guard. I think we can assume that our input is correct, but let's go ahead and just be good here. Let's say if guard X equal -1 or guard Y equal -1, then echo, could not find guard in input. I don't think this is necessary. I think we can assume the puzzle is valid, but let's just go ahead and be good. Make sure we found the guard. Let's go ahead and comment some of this stuff. Read in the data and save it into the grid. also find out where the guard is. Cool. I like that better. Cool. So now, if this is correctly, or if this is done correctly, we should have puzzle width, puzzle height. Guard location equals guard X, guard Y. Let's go ahead and run this. And cool, guard location is 4,6. Hey, that seems really, really nice. So now we know where the guard is. We know that the guard's initial direction is up. I think it's always up. Print what we have so far. Guard always starts by moving up first. Okay. So, what are we going to do now? We have the puzzle in this thing called grid. I'm trying to think if we have a nice way of printing out grid, if that's worth it. If I should write a function to take this associative array and print it out. We probably should. Yeah, we should probably have a function that does that. So let's go ahead. We're going to use width and height in that function. Yeah, so let's go ahead and make a nice little function called... whoops, that's not even right. We'll do print grid. So this function will print the current grid out in a nice, easy to read fashion. So we will do for y equals 0, y less than height, y plus plus. Do for x equals 0, x less than width, x plus plus. Do done, done. Local y, x, so we don't bleed into the global scope. Although I don't know if you define them inside a for loop, if they do or not. I should probably double check that. So what do we have here now? We need to grab the character from that. So local c equals grid x comma y echo dash n c, and then echo here, and that should print the grid. So if that's all correct, then we can do print grid down here, and the last thing it should do is reprint the grid. It printed nothing. So that didn't quite work. I'm going to go ahead and get rid of the echoes here because this isn't useful. That's just creating a lot of output. So the output will now look like this. And you can see I would like it to print something here, but it looks like C is always set to nothing. Why is that set to nothing? Let me try this. Local key equals x comma y, and then we will just do key grid. Still doesn't work. Now, why might that be? Did I remove the part where I was saving it in the grid? I think I did. You never set grid. Yep. Yeah, I just noticed that too. Yeah. I went through and did all this nice little work. I found the guard, but I never actually set the grid, so that's really funny. So let's do key equals x comma y, grid, key equals c. There we go. Now we save the grid. Hey, look at that. Now, does that look like our original input? It does look like our original input. That's beautiful. The benefit to this is that now we have a really nice way to print the grid. So when we're doing work, we can do really quick debugging by being able to print the grid and make sure everything makes sense. So let's go ahead and step through it. So we're going to constantly step while she is still in the map. So while she is still in the map, we don't know what that condition is going to look like yet. So let's just say while true. We'll do it in a while true loop, and then we'll break out when we need to, and we'll come back and revisit this conditional and figure out exactly what needs to be done. So while true, try to move the guard and see what happens. So the way I want to move the guard is we're going to have a new x and a new y. What that means is we're going to try to see what it would look like if we move her in that direction. Then we're going to check that spot in the map And if it's valid, we'll commit to moving there. If it's invalid, then we'll figure out our course of action. It's only going to be invalid if we hit a pound sign or we walk our way out of the map. So let's go ahead and do this. Imagine what it would look like if we move her. Okay. So now we check if new x is, we have to check if it's inbounds now. If new x is less than 0, or, sorry, is it or? It is or, yeah. New x is greater than or equal to width, or new y is less than 0, or new y is greater than or equal to height, then echo she left, LOL, and we can break out of this loop. Cool. So there's our bounds checking right there. So what we can do now, this loop will just run forever because we're actually not doing any work. Check her bounds, check for collision, I imagine. Figure out how to move her based on her direction. Cool. So we'll do a nice little case statement over her direction because it's going to be a string that has 4 different possibilities. It's basically an enum if this was a different language. Case direction in up, down, left, right, and then this will never happen. We could put error checking there. I'm not even going to bother. So if we're trying to move her up, then we want the y to go down. Might sound confusing, but we're starting with y equals 0, and then as the number gets higher, we're moving down. So if the number gets lower, we're moving up. So new y minus minus. New, if we're going down, then new y plus plus. If we're going left, then new x minus minus. And if we're going right, then new x plus plus. That seems very simple. So the next thing we do is we check our bounds. Let me put this down here so I don't forget. If we are here, she has walked out of bounds. Cool. So now we check our bounds. That's cool. Now we need to check for collision. If, let's get the character at that spot. So new C equals grid at new x. Let's just do it this way. Key equals new x, comma, new y. Key. Now we will check what this is. So let me think about this. I think we can do a nice little case statement here. If it's a period, then we are free to move here. And the way we will do this is we will set that spot in the grid to be her and the last spot that she was to be a period. We're going to swap them. Okay, that's easy enough. Let me think about all the possible cases here. The other possibility is that it's a pound sign. And if it's a pound sign, then we have a collision. And the only other thing she could run into would be nothing. We've already checked the bounds, and she's not going to run into anything else. So let's make our life a little bit easier. We're just going to make a fatal function. Echo whatever arguments they gave us, send them to standard error, and let's exit here with 1. That way, we can just simply call fatal. And we can kind of just add error checking. There we go. We get nice little error checking for free. That way we can do something nice here. unknown grid char new C, and we're done. Okay, cool, almost there. Let's take a break. Let's look at chat. I did this one yesterday in Python, and I've been hoping you do it in Bash. My part 2 was far from optimized and was tricky. You know what? Someone else in the chat said that the part 1 was easy and the part 2 was a brute force one. So we shall see what happens. But yeah, I'm excited for this. I feel like this is a fun one. I like this idea here. So if we hit a period, then we are free to move here. So what we do then is we will say grid new X, new Y, this is where we're going to move her, equals her. So this is our guard. And grid X, comma, Y, this was the previous position, that was her, is now going to be a dot. So we're basically swapping her in them, and we're leaving everything else the same. I don't think there's anything else we need to do except set X equal to new X and Y equal to new Y. Cool. That's how we will handle moving her. So now we need to handle a collision. So if there is a collision, we need to move her direction. Okay. So we need to do case direction. Let me think about this. Let's look at chat. Need a counter of number of moves? Yeah, I'll worry about that later. I'm just more or less figuring out how to move her first, because then we have to figure out. We don't have to count how many moves she does. We have to count how many unique positions she go in. It'd be cool to see how many moves she makes, but if she moves over the same spot she's been in, then I don't think that counts. I think we need to count the number of unique places she's been. So I'll use a hash map for that when I get to it, though. Case direction in. So let's handle all of the possible directions. I already have them here. So she needs to move 90 degrees to the right. So we just have to calculate that here. We have a collision. Turn her. So if she was going up, she is now going right. If she was going down, she was now going left. If she was going left, she is now going up. And process of elimination, if she was going right, she is now going down. Cool. So we've effectively turned her. And now that we've turned her, there's nothing else we need to do. We just need to move on to the next iteration. Right? Yeah, all we've done is turn her. Because then we will just check again. I think this is it. Now, we don't have any sort of logic to test how many moves it takes or whatever, but we can add that. So let's go ahead and print grid, I think I called it. Yeah, I called it print grid. And then what we'll do is we'll put a read command here. Now this will block until I give it some sort of input. Let's say read-n1. This will block until I give it any sort of character. No, let's just leave it as read. I'll hit enter. This will block until I hit enter. So we can hit enter and kind of watch her walk around. So that should work. All right, let me check chat. If you leverage your solution from part 1, it definitely helps part 2. Oh, absolutely. I pretty much start part 2 by always copying over part 1 in place of it and then working from there. Count the number of X's? Yeah, exactly. All right, let's see what we got here. Part 1, read in from example input. Unknown grid char. That. Okay, where do we have that? Oh, we found her character, right? Well, no, we shouldn't have found her. Did I put this anywhere else? Grid char. Does that only appear in one spot? That does. Why did we find her at the new C and the new R? Why did that happen? Because in Bash, we don't fall through. Case statements don't fall through in Bash. So I don't have to worry about any sort of weirdness with that. Why did that happen? Okay. We moved her up and well, it's definitely wrong that we have her moving up, but it's definitely wrong that it's printing twice. All right, let's figure out why that is. Okay, so the first thing we got is move her. That's great. So we moved her. It seems like something here didn't quite work the right way it should have. Oh, I know exactly what's going on here. I just used the variables x and y. Those don't exist. They were guard x and guard y. And they were guard x and guard y. Oh, there we go. Oh, wow. Okay. Cool. So a lot of stuff happened there, and it looks like the read command didn't quite do what I wanted it to do. It shouldn't have blocked. Am I crazy? That should have blocked, right? Yeah, it blocks until I hit enter. Why didn't that work? Oh, because I read the puzzle from standard in, so it didn't actually block because standard in was already closed at that point. All right, so read would have just failed. So let's try this. We're going to try something crazy. Let me think about how I want to do this. We'll sleep 1, we'll clear, and then we'll print the grid. Let's pause here and look at chat. Let's see. Not true. They don't by default, but they can if you want them to using semicolon, semicolon, ampersand. You'd never know it, but Bash has one of the most robust case syntax of all. That's interesting. Is that true? I don't know if I've ever seen that syntax before. I don't think I've ever seen that. I don't doubt that it's true, because Bash has some wild syntax that I'm still learning. But if that's the case, I don't know if I've ever seen that. That's crazy. Let me think about... We're going to get completely derailed here, but now I'm curious. Let's make a file called case user bin env bash I equals 5 case I in 5 echo first 5 echo second star echo anything esac. So if this works, this is the normal syntax. This should just print one line. First, cool. Let's go ahead and look at the syntax you've given, which was to put an ampersand at the end of these. So these should now fall through. If I get rid of this, it should stop at the second one. Listen, man, you taught me something new about Bash. That's beautiful. I had never seen that syntax before. That's wild. That's cool. I wonder when that was introduced. Like, do you know what version of Bash that became available? That's crazy. That is super cool. I had never seen that. It's interesting it doesn't do it by default, so they had to add that later. Damn, okay, what a wild syntax. That is really cool to see. That's super cool. Yeah, I'm curious now. I'm going to look through the source code and see like when they added it. Do I have the source code on here? I don't have it on here. I don't want to pull it. It'll take too much time. I have it on my other computer. I could have taken a look. That's wild. Does this work? A token that performs a control function is one of the following. I mean, yeah, look at this syntax. Like it's mentioned in the Bash man page. So that is crazy. Can I just put an ampersand here? I can. Wow. Yeah, look at this. Case word list. Yep, we see it. If the semicolon operator is used, no subsequent matches are attempted after the first pattern match. Using semicolon ampersand in place of semicolon causes execution to continue with the list associated with the next set of patterns. Using semicolon ampersand causes the shell to test the next pattern list in the statement, if any, and execute the associated list on a successful match. That is insane. Huh. That's crazy. Yeah, I had never seen the syntax. I'm gonna go find what version this was added, because I'm super interested in that. I had never seen that syntax. That is super cool. Yeah, thank you for this. This is crazy. So far we have what do you have? Bunyan? Bunyan and oh man, my buddy Mustache from TikTok showed me something new, parameter transformation, that I had never seen. So I'm keeping track of all the people who have taught me new things. There's way more people that have taught me new things, but yeah, dude, that's super cool. Thank you for showing me that. That's crazy. I'm gonna have to do a ton of testing around that. Oh, there was someone else who taught me, and actually I used it in Advent of Go to continue, break all these built-ins to Bash. They take a number too, so I can break out of 2 lines of or 2 loops or whatever, which is really cool. So like help break. You can see break has an optional N here. So if you're like 3 loops in, you can break 3 and knock yourself out of all of them. Like in Rust, I would have like a label or something, but in Bash, I can just give it a number. So that's super cool. Yeah. I love that if it's not all or nothing, it actually continues subsequent cases. Yes, exactly. That's super cool. Like it's cool they give you those options. It's just, man, Bash has some gnarly syntax that you totally just have to memorize, really. So this is going to be a short, I guess. Almost certainly. I double and triple dip into my content all the time. I think anyone who streams should be uploading VODs, re-editing them, making them shorts, like make them accessible everywhere. Because I constantly get questions like, wait, where are you streaming this? It's like, hey, I'm on YouTube. And the next thing you know, I got someone from Instagram coming over to YouTube. Totally worth it. That's my advice to any content creator. Double, triple, quadruple dip as much as possible. Who sucks now? That's the joke. I never said I didn't suck at programming. Man. I didn't know that about break. Hey, that's awesome. That's cool. And that was something that someone in the comments actually brought up to me, which I was like, hey, that's sick. There's so much about Bash. I just don't know. Like there's so many things to learn. Parameter transformation is definitely a really, really cool one. If you haven't seen it before, you could say like foo equals hello. And then you can do this notation, which, I mean, we're all kind of used to, where you could put like a colon here and like break into it. You could do this notation, but you can do an @ sign, and then there's a couple different letters. So like, I need to put a quote there. You can do this one, which is super cool. It will print a safe to execute in the shell version of it. So this will be quoted properly because Bash ensures that it's quoted properly. There are some other ones, like K is another one, Q for quote. K can handle arrays and stuff like that. L, I think, is one of them. Yeah, L is for lowercase, U is for uppercase, lowercase u is for capitalization. There's so many of them. You have to man bash and look for them. There's another one that was super cool. There was like a declare notation. I'm just guessing at the syntax now, so don't quote me on this. Let me man bash real quick. I think it's transformation. Parameter transformation. Yeah, so here's a whole list of all those characters you can use that come after the @ sign. What is the one I'm thinking of? Oh, A is really cool. A is super cool. I'll show you that one. Oh, A worked. Right. Okay, A worked for me. And then P handles it like a prompt. Oh, okay, so this one's cool. Yeah, so if I had like a variable foo equals \w, I can print foo with the @ sign P, and it will turn it into my current working directory because that's how it would have been processed if it was in the PS1 variable like prompt, which is super cool. If you declare read-only foo equals hi, you can echo foo with the A, and it will show you the exact declare command you ran, and this will be safe to run in your shell. It'll be done safely. And then just lowercase a just shows you R. This was the flag given to declare to create this variable. So this is super useful. If you're debugging code and you're like, I have this variable, but what is it? You can do this and it will tell you the exact arguments that would be given to declare to create that argument, which is super useful. So I've actually been I haven't finished it. I've been working on a function like var dump basically for Bash, where you give it a variable and it will handle it for you. Because there's really no good way of doing that in Bash. But if I do like declare -a array, and then I say array foo equals 1 and bar equals 2, I wrote a little function called prr to print array, and it prints it like that. But I've been working on cleaning this up and trying to make it handle every possible variable type. So it'll say like, oh, you wanted a var dump on this? Cool. Here's what the variable is. Here's how it was defined. It's read only. It's an integer. It's an array. It's whatever you want. And then it prints it out nicely for you. You can't read it back in. Don't try to do that. This is just for a developer to look at. Whew. Okay, let me pull back up chat because I'm kind of going off the rails here. Yeah, it's huge. There's so much about Bash. It's crazy. Oh man. Oh, man. Yeah, Bash is awesome. SpongeBob case. Yeah, I wish that was real. Yes, yes. Declare dash I is something I stay away from because there's so many gotchas with it. But it is so nice because I could say declare dash I num equals 5. Num equals not a, let's say, not a number. That looks like it was successful, right? But if we echo num, it's set to 0 because the attribute associated with the function num is it must be an integer only. We can verify that by looking at the attributes of num using parameter transformation. We can see that I is set on it, I for integer. So it's really cool. I want to like it, but man, there's just so many weird gotchas with it. So yeah, it's wild. Oh man. All right. Enough being sidetracked, but thank you for that. That was super useful. That's super cool to see. Let's go ahead and where were we? I think we were going to run this example and we should sleep, right? What? Okay, iTerm is being super annoying. Is it going to just tell me that? What? Yeah. Allow it. I don't care if it controls my scroll back. That was super annoying. Okay. Let's go ahead. Let's go ahead and make this sleep a 0.3 so we don't get bored. And we're going to watch this animation. This is working. Look at that. She's moving down. Now she's moving left. Now she's going to move up. Now she's going to move right. Now she's going to move down. Hey, this is working. Now she's moving left. Now she's moving up. Now she's moving to the right. And she's going to walk off screen. There we go. This works. How awesome is that? What a beautiful little animation that plays. Oh, boy. That is super fun. I think there was a little bit of flashing there. We can probably get rid of that by generating the grid first, like display equals this, because I think it takes time to generate the grid, and then after we clear it we can echo display, and then we'll get rid of that whole like stuttering that we were seeing. There we go. That looks a lot cleaner, doesn't it? Perfect. Perfect. Nice. T put civvies. Yeah, doesn't that just make my cursor invisible? Yeah, I think they'll just make my cursor invisible. There's a whole bunch of stuff I could do. I could do, was it tput sm cup? So I could go to the alternate screen and then tput rm cup when I'm done. I'm not too worried about making this super nice at this point, but it is cool to watch her move around. So now that we have her moving around and it works, we need to actually gather some metrics. So let's figure out what metrics we need to get. We need to figure out the distinct positions on the map that she went. So this is another place for an associative array. We'll make an associative array and we'll keep track of places seen. So declare dash a places, or we'll just call it seen. Let's see. Let me look at chat real quick. Are you going to rotate the arrow? I could. I have no real desire to do that. Also, what would I use to symbolize a down arrow? I have no real desire to do that. Honestly, I'd probably just make her something else if I wanted to. I could just make her like a G for guard or something. But I totally could. Let's get rid of turn her. Let's get rid of move her. What do we have? We have seen. So every time she sees a new location, meaning every time we move her, we will keep track of it. So seen, guard X, guard Y equals, we'll just set it equal to like true. That'll just be literally the string true. And then we have to keep track of the first location we've seen her in, because she always starts in the spot that she starts. That counts as a unique spot. So now, every time we do this, at the end, we can check how many items were in scene. So I think we can just do this. Distinct equals scene. And then we just put this pound sign in front of it, and that will get that echo visited, distinct positions. I think we should just be able to do this. Let me look at the chat. V. Oh my god, you guys are right. We could just use V as a down arrow. Let's see. True Bash developers use plain VI, Control Z, BG, and FG as an ID. Hey, I come pretty close. I'm using Vim, and I've somehow figured out the secret to escaping Vim, so I'm close enough. I'm close enough. Yeah, exactly. Add is the real editor. Let's see. Okay. I think I'm gonna use I could printf. I'm not even gonna look at I can see that printf will print some character. I'm gonna assume it's some sort of down arrow, but I'm gonna stay away from that. I'm also probably not gonna run commands that people give me, even though that most likely is safe and that's what you're giving me. But I'm gonna stay away from that. Let me come up with the guard. Do you want me to do the guard character? Would that be cute for you guys? Would you guys want that? Because we could do that if that's what you guys want. Let's see. How would we do that? We'd have to come up with what the guard char is here. So, case, direction, in, up, guard char is this, down, left, right, down is a V, left is this, right is that. ESAC. We'll set this new one to guard char. There you go. Is everyone happy? We'll see if this works. So. Hey, look at that. Look at that. That is beautiful. There's one little thing that's annoying me. When we switch her direction, when there's a collision, we do switch her direction, but we don't actually reset her character to technically look the other way. So we could literally just do this. I'm copying and pasting code, but here we are. That's not where that goes. Why is ESAC in there like 8,000 times? I think this will work. So now we'll see a moment where she switches direction. Oh, oh no, she's propagating. She's becoming. Okay, this is a bug, but it's actually really cool because you can see the direction she started moving because of the collision. So like, it's a bug, but that looks really cool. I actually really like that. I have to say that's pretty neat. Yeah, because we don't want to update that. We want to update this and this. Okay. Oh boy. What am I doing wrong here? Oh, I did Y and Y. Yep. She leaves a log. Yeah, exactly. She writes down what direction she went. Hey, this looks really good, doesn't it? Look at this. I love it. We will have to speed up the animation for the real input because I think it's going to be gigantic. But visited 41 distinct position. Look at that. Let's make it plural. That way, if the answer is ever 1, it still is grammatically incorrect. So 41 distinct positions. If we pull back open the web browser, we can see that she was supposed to hit 41 distinct positions. So that's beautiful. Now we can go through, give it the real input, and we should be able to calculate that. So I just want to see. Okay. This might be fun to visualize later when my terminal isn't so stretched out. Do I want to do that right now? It would be kind of fun. Hold on. What did I call it? Is it 2024? Advent of Code? Day 6. Part 1. Read in from real. Oh, it's too tall. Oh, but I can see her moving. Oh, that's so funny. Oh, it's too tall. That's okay. We won't do the visualization here. We'll just get rid of this visualizer. That'll be fun to do. It'll be really fun. I'll probably go through and make some sort of fun visualizer for this, but yeah, let's just go through and run the calculation. What we can do is we could echo a dot so we can keep track of our progress. So that'll be kind of fun. Actually, yeah, we'll just echo a dot. We'll echo a dot, and then we'll echo here when we're done. So let's do this. Let's do this. Let's do this. Visited 4433 distinct positions. You want a counter? Let's do a counter. You know what? I'll give you guys a counter. Let's do this. Let's do counter equals 0. Not needed for the puzzle. Just fun. And then we'll do a nice little counter plus plus. Cool. And then what we can do is we can printf. We could printf the counter. What should we do? Maybe like 04D. Let's just do 5D dot 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 \r the counter. So now let's do a tiny little sleep, just so it doesn't go super fast. And let's see. That's pretty cool. I have to say, this is pretty cool to see like this. Because I think it goes up to 4,000, right? This is fun. It makes it look like we're really calculating something tough, even though Bash is way faster than this. There we go. Oh, it overwrote and it said she left. But yeah, so it looks like she made like 4,800 moves and 4,433 were distinct of that. That's pretty cool. This is pretty cool. Let's see. Nick, hey man, binging your videos lately? Yo, thank you. I appreciate that. My YouTube growth has actually started to pick up a little bit, and I'm super excited for that. My goal was to hit 15,000 subscribers by the end of the year. I think I'm going to hit that by the end of the week, which is, only a couple weeks away from the end of the year. But still, that's really cool. So let's go ahead. I think I have the answer here. Let's try and plug it in over here. That's the right answer. You are 1 gold star closer to finding the chief historian. Beautiful. We did it, everyone. Part 2. While the historians begin working around the guards' patrol route, you borrow their fancy device and step outside the lab. From the safety of a supply closet, you time travel through the last few months and record the nightly status of the lab's guard post on the walls of the closet. Returning after what seems like only a few seconds to the historians, oh, this is cute, they explain the guards' patrol area is simply too large for them to safely search the lab without getting caught. Fortunately, they are pretty sure that adding a single new obstruction won't cause a time paradox. Oh, God. Oh, please don't know where this is going. They'd like to place the new obstruction in such a way that the guard will get stuck in a loop. Oh, that's neat. Making the rest of the lab safe to search. To have the lowest chance of creating a time paradox, the historians would like to know all of the possible positions for such an obstruction. The new obstruction can't be placed at the guard starting position. The guard is there right now and would notice. In the above example, there are only 6 different positions where a new obstruction would cause the guard to get stuck in a loop. Holy God. Oh boy. The diagram of these 6 positions use O to mark the new obstruction, pipe to show a position where the guard moves up down, hyphen to show a position where the guard moves left right, and plus to show a position where the guard moves both up down left right. Option 1, putting a printing press next to the guard starting position. Okay, so oh yeah, you're right. Okay, so that would cause a loop. Option 2, put a stack of whatevers in the bottom right quadrant of the map area. Oh my God, yeah. Oh, and then they walk into that loop. Okay, I see. Option 3, put a creative whatevers. Okay, so they go up here, they go here, they go here, and then they get stuck in this loop. Doesn't really matter what you choose to use an obstacle so long as you and the historians can put it into position without the guard noticing. The important thing is having enough options that you can find one that minimizes the time paradox, and in this example there are 6 different positions you could choose. You need to get the guard stuck in a loop by adding a single new obstruction. How many different positions could you choose for this obstruction? Oh my God. I have no idea how I'm going to do this. No one give me solutions, but I think I'm going to probably end up brute forcing this. But please, no one give me suggestions. But My God, what a day 2, or what a part 2. Let's read chat. You inspire. Yeah. Ooh, wow. You inspired me to write my first bash program to generate a day for AOC. Keep going. Yo, that's awesome, man. I'm super happy about that. I'm glad. And hopefully it was fun, because like I find these puzzles to be super fun. I really love your vids, man. I wish all the best to you. Yo, appreciate it. Appreciate it. Thank you. Brute force smartly. Yeah, I gotta figure out how I would even do this. But, all right. CP part 1, 2, part 2. Okay. Run part 2. Oh, I don't have my terminal open. Run. All I did was CP part 1 to part 2. Run part 2 on the example input. Okay. Let's go ahead. Let's go back to visualizing this because that was actually super useful. We don't need the visualizer anymore. I'm editing part 1, aren't I? Yeah, I am. Let's just CP over it again. Okay, part 2. Okay. This is easy enough to follow. 0.3 is a little bit slow. Let's just do like 0.05. This will go pretty fast. Cool. That's fun to watch. That is really fun to watch. I like the visual aspect of this. It's easy. Just test to see if you're in a loop by solving the halting problem. That's literally the first thing I thought of when I was reading it. I was like, oh, so let me just solve the halting problem. Let me just solve like the hardest problem in computer science. Yeah, let me just do that real quick. Oh man, that's just so funny. All right, so we have to figure out where to put an obstacle that would cause a loop. I actually don't even know how you would. I don't even know how you would come up with an algorithm to say, give me all the places where a loop could be constructed. I'm trying to think of this. You'd have to like unravel this 2-dimensional array into some 1-dimensional representation and then figure out if something stops going out of bounds. That's very amorphous, what I just mentioned. There's got to be some way. There's got to be like some mathematical proof for this, but I'm thinking brute force might be the answer. Oh, man. Yeah, if debug do a visualization. I agree with that. I do totally agree with that. And it's just easier to not do it, but I'm going to do it. Okay, I'm going to do it. Debug equals false. While getops, we'll do D for debug. Opt do, case opt in, D for debug. Debug equals true. Fatal. All right, we'll just do an exit 1 if you give it something bad. ESAC, done. There we go. Now we have argument parsing. So now, if debug, then there we go. There we go, done. So now, make this easier for myself, I'm going to cat it and pipe it into part 2. That way I can just tack on the dash D and remove the dash D when I don't want it. So this should just be real fast. Yep. And then this will actually give me the visualizer. Very good suggestion. Appreciate that. Oh, man. Let's see. Okay. We have to figure out if we can add and then we have to figure out if she's in a loop. How do you figure out if she's in a loop? Because yeah, what we need here is we need some sort of loop detection algorithm. And the loop detection algorithm would simply be like, she never gets out of her bounds. But how long do we run the simulation before we determine that she never gets out? So I'm trying to think of like how many paths she could possibly take. I think I'm approaching this the wrong way. Instead of trying to figure out if she never gets out, I think we might actually have to detect if she's in a loop. Now, how would you detect if she's in a loop? I think the easiest way to detect if someone is in a loop is if you are visiting the same spot. So if you've already seen this spot and you're moving in the same direction, if you're at a spot that you've already seen and you're moving in the same direction, you will be in a loop. Guaranteed. Has to be. So where we keep track of seen, we keep track of it with the Boolean variable true. We should instead keep track of her direction. This will be her direction when she has seen it. And then we can do a check here. If that already exists and is the same direction, then we know that she's in a loop. I think that's the way to do it. Let me check. Chat. Don't fight it, you're in bash. Embrace the brute. Global counter? Yeah, something like that. I realize those are probably old compared to me just working through my mental track of it. Yes. We've been asked to not tell the answer, but I have a suggestion when you want it. No suggestion right now. I appreciate it, but yeah, I'm gonna try and knock this out. Also, I suspect I'm behind the stream somewhat. So whenever you hear me say that, that was a split second after seeing your message come in. So that will be your determination of how behind the stream you are. If you're watching on YouTube, there might be a button that says live and you can click. Sometimes it gets a little bit behind and that's super annoying. Here's the tough part though. If she sees the same place and she's not moving in that direction. Let's leave this. Let's leave it because we still need to know. Oh, we don't wait. No. We don't need to know how many. Oh, I have an idea. That's my idea. We will keep track of the X, Y, and direction. So it's basically a tuple of these three things, the X, Y, and direction, and then we'll keep track of if we have seen this. So what we can do is we can say if -n seen key. If we have seen this, then we know that she is in a loop. Then echo loop detected. We need to break out of this, right? Let's worry about that later. Loop detected. Otherwise, we set the key and we move on. So we'll probably have to move this into a function. And that's okay. All right, let's see. What if we check if we put an obstacle in the next position? There are 3 hash that forms a square. Suggesting I didn't try. That's an interesting one. Oh, that's an interesting one. Yeah, if you just put the obstacle directly in front of her because she's only ever going to react to obstacles directly in front of her. I see what you're saying. Yeah, put an obstacle in front of her and then test. Put an obstacle in front of her and then test. I think that works, right? Yeah, you put an obstacle in front of her and then you run a simulation and see if she's in a loop. Then you pretend that obstacle wasn't there, have her move forward again, then put another obstacle in front of her. We could totally do that. That might be the way to do it. But let's try dumb brute force first. So let's see. So we can detect loops now. I think the way we should test this is put her in a loop. So I'm going to go ahead and modify the example input and manually put her in a loop. And the way I'm going to do this is I'm actually just going to look at the example over here and just copy one of them. So the way that they have put her in a loop is by putting a thing here. So this one next to her shouldn't exist, but this will put her in a loop. So if this works, she should detect it. Loop detected. Cool. Our loop detection logic is working. That's really good. No, don't delete it. Okay. So our loop detection logic is working. So now we can detect if she's in a loop or if she's able to walk out of it. We want to detect a loop. We care about loops. So let's put this here. Number of loops we found, because loops are good. That's the thing that we want. We want to find how many things will result in a loop. So we'll put a counter there. And every time we detect a loop, we will increment loops. And then what do? We break out of this loop. Okay. I have an idea. It's going to be a little gross. Let's move all of that logic into run simulation. That's what we're going to do. So we're going to take all of this logic here, and we're going to put it in run simulation. And we will clean it up. I might leak some variables here. I'm not going to worry about that right now. There's going to be some unclean code. That's fine. So run simulation, what this will do is it will set her direction. Don't even bother printing the grid. I don't care about that. We have seen where she is. I don't even think we need to count this anymore, to be honest. Oh no, we do need scene. Sorry, we don't need, that's what we need. Get rid of the counter. Number of loops we found. No. We want to return. Here's what we want to do. We're going to return 1 if she leaves, 0 if this loops. Because those are the only two possible cases. When we run a simulation, either she'll leave or we'll loop. So if she leaves, then we return 1. And if she loops, then we return 0. Okay. That is great. So now we have the ability to run this. We don't care how many places she's been. So now let's go ahead and run this and make sure it works how we expect it to. Okay. If run simulation, then there was a loop, num loops plus plus, num loops equal 0. All right, let's look at chat. Let's see. Instead of counting the loops, you might want to store the XY position in case a spot is encountered more than once. I don't know what you mean, but I think I'm onto something. So I'm not going to take an input right now. I'm just going to go with what I think is working here. So that's how many loops we've encountered. So the simulation is only going to run once. Okay. Now I think what we need to do. Yeah, I was going to brute force the entire puzzle by putting an obstacle literally at every single possible thing. I think that's going to take too long, because if the puzzle's 10 by 10, suddenly we're taking 100 times longer to run this whole thing. We have to test that many. So I think we're going to have to, let's try that and let's see how slow it is. For y equals 0, y is less than height, y plus plus, do. For x equals 0, x is less than width, x plus plus, do. Done, done. Num loops going out of here. Then we need to run a simulation. So the way we're going to do this is we're going to add an obstacle here. So we're going to see in the grid, we'll take the original character out of the grid. Like this. Take the original character out of the grid. If we can only change a period. So if orig equal period, then we will set grid x, y equal to this. This is our own obstacle. We are going to add an obstacle here, and then we are going to run the simulation, and then regardless of how that simulation works, we are going to reset that back to a period, and we're going to run phi here. This is extraordinarily brute force. Extraordinarily brute force, LOL. So we're going to go through every single possible puzzle. Echo testing puzzle x comma y. So let's do this. Total puzzles equals width times height. Current puzzle equals x times y. Testing puzzle, current puzzle out of total puzzles. We'll get an idea of how long this will possibly take. But this logic should work. It just might be incredibly slow. Let me double check here. Let's see what's going on. Width times height. That's the total number of puzzles there are. For y equals 0, y equals height. Hey, look at that. Let's be smart here. X equals 0, x minus or less than width, x plus plus. Current puzzle is these multiplied together. Testing puzzle, current out of total. Get their character from the grid. Check if it's a period. If it's a period, we set it equal to a pound sign. Then we run the simulation. If it returns successfully, that means there was a loop. And then we set it back and we try again. This should work, but oh my God, is it going to be slow? But let's run it. Something broke. Oh, I know what's happening. Yep. That was cool to watch, but I think I'm overwriting guard X and guard Y and not resetting them to all of the defaults. So what we should do here is, where do we get guard Y and guard X? Okay. Original guard Y equals guard Y. Original guard X equals guard X. There we go. And then when we run a new simulation, we should reset these variables. This could be guard underbar. This could be guard direction too, because that might even be simpler to understand. But for now, original guard X. Okay, I think that's better. So let's go. This is fun to watch. Okay, and I can see it adds a new thing. Unknown grid character V. Oh, you know what? When she leaves, I don't know if we reset the grid. So we should probably do that. Let me double check here. Oh, you know what it is? Yeah, it's because we're using all these directional things. And then I think we're leaving them in. We'll have to check. We'll have to check. Let me remember how to do this. Where does she leave? I think I put like left LOL, right? Yeah, she left LOL. Why don't we just do this? Why don't we just... How do you copy... Can you copy an entire array in Bash? Or do I have to do it key for key and like really... Oh, I might have to do that. Yeah, because I would like to start with the like original grid. You know what I mean? Hopefully that makes sense. I don't think you can just copy an associative array to an associative array. There might be a... Oh my God, I know a way. I know a way. Let me do some testing. I'm gonna go look at the chat. Return the location of the obstacle, store that in an array, count the number of entries. Current puzzle doesn't equal the right number. I don't know what you're talking about. Stepped away for a minute. Are you testing every position? Oh, someone else already gave the hint. Yeah, I'm testing every possible position now. I'm going to get an idea of how long it could possibly take. So yeah, if you're giving me suggestions, sorry if I'm ignoring them. I'm not trying to ignore you. I'm just trying to see if I can figure this out on my own. We don't really have pointers here, not in the traditional sense, but I have an idea. I have a really crazy idea. I think I already have array, right? Yeah, I already have that defined. I think using parameter transformation, I think we can do this. What is it? It's like this. I think you do this syntax. Is it K? Capital K? I'll have to probably pull up the Bashman page. There is a way to get it. There's a way to get it to give me a declare statement. Is it just, yeah, I think it's dash capital A. A. There we go. I think I can do this. And then I think this is going to sound so stupid. I think you can actually just like eval this back in. There's gotta be a way to do this better. I can do it the simple way. Like I can absolutely do it the simple way. Here's what we'll do. We'll do it the simple way. I'm not going to make this more difficult than it needs to be. Where do we declare the grid? We'll also declare original grid. There we go. So now what we can do when we read it in for the first time, we can store it in both. Let's make a function called reset grid. So what we'll do here is we will unset grid, declare -a grid. I think we need G for global. I think we can do it this way. This will reset it to nothing. And then we can do for key in original grid. This is gnarly. There's got to be a cleaner way to do this, but I don't care right now. Value equals original grid key. And then we can do grid key equals value. So we'll just have a function called reset grid, and we can run it here. That'll work. Let's go ahead and run the simulation and see if that works. Basically, every time we finish, we're just going to overwrite that variable that we've been using with the original variable that we have stored. That looks way better. I don't see the obstacle moving. Okay. So let's do some cleanup here. Let me pull up the chat. We'll see what's going on. Let's go. This is going to be gnarly. It is going to be gnarly. Neat. I copied the array key by key. That's exactly how I did it. Exactly. Let's see. You've got current puzzle equals X. Well, I don't know what I have. Let's find out. Yeah, X times Y. Oh yeah, that won't work. Right. Yeah, you're right. Because what I want is something other than what I have right here. Yeah, have a good night. Yeah, take care. Thank you for jumping in. That was awesome. I appreciate it. Yeah, because what I want is I want X times Y. I want to add it to Y times. I want to do something here. I can't. My brain's not giving it to me right now. What do I want to do here? What am I trying to accomplish here? Yeah, do I just, is this what I want? No. No, I want to add it to Y. No, no, I want some sort of unique index. What am I doing? What am I doing? What am I doing, guys? Current puzzle equals 0. There we go. current puzzle plus plus. What am I doing? What am I doing here? Oh my god. I can just do it this way. Yes, column plus row times line. You're right. That is what I'm trying. That's what I was trying to do, but I can just count them. Let's pipe it to part 2, debug. I don't love that we lose track of the testing puzzle thing because we clear the screen every time. That is annoying. Let's just sleep 1. Now where's the pound sign go? I don't see the new pound sign. Did we add the new pound sign? I don't think we did, right? Yeah. Okay. I got it here. Run simulation. Run simulation resets the grid. We don't want to do that. We want to reset the grid here. And then we want to set grid X, comma, Y to... oh, no, we already do it. We already do it here. So we need to reset it here because we were resetting it inside the function. Yep. This is what we want. Okay, reset the grid and then set that one. Okay, we were just doing things in a weird order. That's fine. Cool. Now we see the pound sign at the top left. And when this simulation's done, the pound sign should move. There we go. Awesome. Awesome. Yep, so this is brute force. We're going to test everything. You already have the visited path. You only need to test those spaces for new obstacles. I know. Someone already told me that. Put the obstacle in front of her and see what happens. I completely understand that. I want to see what the fully brute force method looks like. So that's why I'm doing it this way. Let's get rid of the sleep. We're not going to debug. Let's get rid of the sleep here. Let's see what this looks like. Okay. So 5 of them created a loop. Okay. So if we pull this back open, what should we have gotten here? There are 6 different positions where a new obstruction could cause the guard to get stuck in a loop. And we came up with 5. So something's not right. Why are we off by 1? That is the programmer's plight indeed. Okay. No loop, no loop, no loop. Why does this one not even print anything? How do we break out of that one without printing anything? How is that happening? We have a loop, and we have... Run simulations in a while loop. And we don't even have any sort of break statement, so it has to return out of it. Return run or we return 0. That's the only way we can possibly get out of there. Okay. I'm going to make this puzzle 1, so that makes more sense. We'll actually count up to 100. Oh, yeah. We print that we're testing the puzzle, but then there's already either she's standing there or an obstacle standing there, so we throw it out. Yeah. Cool. This is a lot easier to read. Cool, so we have a loop. Yeah, loop, 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 loop. Yeah, we got 5 loops. Okay, let's go back to chat. Because there's already an obstacle there. Yes, exactly. Yeah, I realized that. Whoops. When a loop found, you could spit out the XY so you know which positions hit. Yeah, I could. If cur is already an obstacle. Yep, yeah, exactly. Why am I only detecting 5 loops? How is that the case? Am I skipping one that should be a loop? I think you're right. I think I should print out when there is a loop detected. I should print out which one caused the loop. So X, Y caused the loop. All right, so we can see which ones caused the loop. 3, 6, 6, 7, 7, 7, 1, 8, 3, 8. Oh boy, this is gonna be a nightmare to go through. Yeah, because I have to reference this with the original puzzle. Let me double check some things. Is my example input correct? Yeah, I think I turned it back to correct. Yes. I'd have to correlate these with 3 and 6, that one caused the loop, awesome. 6 and 7, that one caused the loop. 7 and 7 caused the loop. Oh, this is just going in perfect order. 1 and 8 caused the loop, awesome. 3 and 8 caused the loop. I'm missing a loop. There was a loop caused at 7 and 9, it looks like. 7, 9 should cause a loop. Well, I don't. I should probably print that out regardless. It's gonna be something. This is one of those things that's gonna be something stupid. It says it's not trying this one. Why is it not trying? Hey. A V shouldn't be in there. How did a V get in there? How did that happen? I wonder if my logic to copy over the grid is incorrect. Because how did a V get written there and not overwritten? Yeah, because a V is my own thing. So she shouldn't have been able to go there then. Here's what we'll do. CP example input to modify.txt. And then I will turn this into the puzzle that should fail. So this is the puzzle that should fail and is not for me. And we're going to run it through part 1. Oh my god. I don't have all day. Come on. No. Okay, so that has a loop. Yeah, so that correctly loops. But for some reason, we don't even bother trying this one. Because it thinks there's a V character. I'm so curious about... Wait. No, this should when you declare it here, it should overwrite any other one that was already written there. So I'm not relying on any sort of global state to do this. Yeah, this variable is not being used anywhere. All right, I'm gonna look at chat. Let's see. Oh, are you breaking out of the map one step too early? I might be. Yeah. Yeah, so what I'm going to do is I'm going to do exactly what you said. I think I'm going to try and print out 7, 9 specifically and just see what's going on with that puzzle. If I had more time or if I cared more, I would make part 2 take an argument and then I can just like give it that one. Yeah, because like this one, that's just stupid. It should not be finding that character. It should not be finding that character in a puzzle before it decides to not do it. Because where it decides to not do it is if it equals a dot, then it tries to do it. It should not be finding it there. If I haven't reset the grid. I haven't reset the grid. I haven't reset the grid. I'm so stupid. Oh my god. Oh my goodness. I should reset it here. That's all it is. I'm gonna get total loop 6 now. I told you. I know I said it, but I knew it was gonna be stupid. I knew it was gonna be stupid. I knew it was gonna be so dumb. Wow. Oh boy. Okay. Okay. Nice. We're getting 6. We're supposed to get 6. Let's go through and make sure this looks good. Cool. I'm just getting rid of some of the debug stuff. Cool. Yeah. Yeah. So I think we're good to run this on the real input. I don't know how long this is going to take. I don't know if this is too much of a brute force and I might have to come up with a faster solution. Faster solution being only look at her path, calculate her path, and then go through and put the obstacles in front of her. Or just put the obstacles in all the places that she visits. Because I could literally do 2 passes. I could go through and see where she visits on the first pass, and then go through in the second pass and loop all of those and just test those. That's way faster, but let's see how slow this is. Here we go. All right. All right. We're 100 in out of 16,000 possibilities. We are 100 in of 16,000 possibilities. Bash is so fast. Here's what we're going to do. I'm going to rewrite this. I'm going to do 1 pass, find out her path, and then create a list of all the places that she's seen, and then we're going to loop over those and try to put the obstacle there and see what's happening. Thread it. Listen, threading it might be a way to do this. I could, yeah. Actually, wait, you're so right. Let me think about this. Because each one runs in its own function. Counting it may be difficult because if you run different bash, I'd have to test this. If I put bash functions in an ampersand, can they modify a global counter? In most languages, just a simple counter is atomic. You are right. You are right that there were 4,433 distinct places. So with that logic, it's still a lot. Like we'd be 20% of the way there, but let it let it run and see if you can create a faster version before it finishes. That's fun. I like that. Use a file as your counter. Semaphores. It'll be quicker to let it run. Yeah, there's a lot of stuff going on here. Literally, I could just let it run. We could also use a file as a counter. That's totally correct. I think we could probably safely use a counter. I'll think about this. I'm going to let this run. I will be right back. I'm going to go grab something to drink from my fridge. All right. Give me like 1 minute. I'll be back. All right, I'm back. Yeah, even if I cut it down to that original list, 4,000 is still a lot. Oh man. No, today we got Dr. Pepper, zero sugar, 0 calories. If you follow me on Instagram, you may know that I've been dieting a little bit, been losing some weight, and I've been making really, really good progress. I'll give you guys a quick little story. In August, I was in the hospital. I'm not going to bore you with the whole story, but long story short, there was a whole bunch of weird health stuff going on and weird unknown stuff. Yada, yada, yada. All that stuff aside, I was still heavier than I wanted to be, higher blood pressure than I wanted to be, and just completely out of shape. So got myself one of these little smartwatches. Been doing 10K steps every single day since I was in the hospital. So August 22nd, I was in the hospital. Every single day since then, I've hit 10K steps at least. I do intense cardio 2 to 3 times a week, and I monitor my calorie intake. I started getting serious about it last month and a half, and I'm currently down from when I was in the hospital. I was 260 pounds. As of this morning, I was 241. So my goal is to get down to like 200, which would be relatively healthy for my height. So that's my goal. But I love soda, so at least I have the 0 sugar variant. As a Brit, this is where I suggest going to make a cup of tea. Yeah, I appreciate it. My version of a cup of tea is I make some nice little hot chocolate. Man, I love hot chocolate so much. Oh, man. Love me some Dr. Pepper? Yeah, exactly. Oh, man. Just wait for end files to exit and then add its contents. You know what? It's not a bad idea. It's a really good idea. It's a really good idea. Every single one writes out. Every single thread would have its own ID, which would be the number of the puzzle. It would write it out to a file, and then we just loop all those files and add it back in. Yeah. I've also been losing weight. Yo, congratulations. That's awesome. Yeah. Thank you. I appreciate everyone saying congrats. Dude, that's huge. Thank you. 10K steps a day? Yeah. 10K steps is rough. I have a treadmill with a desk, and I'll actually plug my monitor in and do work on it. So I'm not walking super fast, but I'm getting my steps in, and it's been good. It's given me a reason to like get up and do work and get the blood flow and all that stuff. So yeah, I appreciate it, everyone. Thank you. Yeah, and nice job losing weight. Like it's one of those things where it crept up on me. It was over the course of years, and suddenly it's like, whoa, I'm way bigger than I thought I was. Like I was always like, oh, I'm a big guy, but now it's like, nah, I'm too big, you know? Sorry, I shouldn't laugh. My solution is similar to yours, but I got the wrong answer. I'm so sorry if that's the case, because my solution is going to take 8 years to run, and I would hate getting the wrong answer after all this. Oh, man. I started a GPL-1 meds, and it has helped me with soda cravings. Diabetic A1C is high. Oh, nice, yeah. GPL-1. Is it GLP-1? I'm not trying to be a jerk. I legitimately don't know. My brain keeps saying GLP. Yeah, I've been talking to some people that are on it. I know some people with like... I have a buddy who's taken that. I have a friend who is diabetic or has some onset diabetes. I don't know the specifics, but is taking something like that. I have another friend, and she has PCOS, so she's been on it, and like everyone's reporting like between like it's somewhat working to like it's really working. So it's cool to see. Like it's cool to see that we have this to like help people with their health. Let's see. This, I don't think we're gonna sit here and wait for it to go to 16,900. But what we can do. No, I need a little bit of a break. Let me go back to chat. GLP-1. Okay, sorry. Yeah, I wasn't like being pedantic. It literally, my brain, like when I said GPL, I was like, wait, hold on. When I think of GPL, I'm like, yeah, like a new public license. I posted a couple videos in your Discord of it running, but it's wrong. I saw that you posted videos of day 6. I purposely avoided that. But yeah, I should join the Discord. Oh yeah. Here, I'll dump a link in the chat. This is my website, and I have everything hung off of my website. So that should get you a link to invite to the Discord. Everything off my website is like that. So I have like /Discord, /YouTube, /Twitter, /Instagram, /everything. And of course, they're all linked to the main site. And of course, you can curl that in your browser. I have to plug this all the time. You can run that to view the website on your browser. Not your browser, your terminal. I'm saying browser, I mean terminal. Let's break out of this And let's put them in a background task. How are we going to do this? I think what we need to do, I have to think about this because there is some global variable stuff, but I think they get copied in at the time of forking it. So I think we can do this. Hear me out. We can do this. How do we keep track of how many background processes we have? I think we have to limit it to like, what are we going to do? Like 10 at a time, 20 at a time, X at a time. I recently saw a video somewhere that you could do an HTTP request in Bash. Did you see the video on my page? Because I totally made a video like that where I used /dev/TCP and I uploaded it. So you may have seen my video. I'm like, yo, what's up, everyone? My name's Dave, and today we're going to make an HTTP request in Bash. Now, let me stop you right there. What you may have heard me say is that we're going to use curl, but no. I said that we're going to do it in Bash. That's awesome. That's awesome. All right. So. I figured that's what you meant. I figured it was a joke. We're all good. I just wanted an excuse to go through it. Capture the return codes. That is a way to do it. That is a really good way to do it. Because I can return one if there's a loop, and we can just add them all up. We might be conflating errors with it, but we can burn that bridge when we get to it. I think everything gets copied when I do this. I think we're okay to do this. Let's make a function. Spawn task. Local ID equals $1. We'll just give it some things. The ID is the current puzzle, and the X and the Y that we're testing. We're just going to give it that. So, oh, this is going to print so many things out of order, but that's okay. We'll worry about that later. So we have a spawn task function. We can put parentheses here. This will create a brand new environment for it. So none of these variables should like bleed out or anything. I don't know what I think. I think they can just access the global grid. I think that will be copied over because of fork and exec. I think we're okay. So we will spawn task, and run simulation is the thing. Local loop equals false. If we are here, then loop equals true. We shouldn't need to reset anything because this should just die out. So let's return, actually, instead of just loop, we'll just say return code equals 0. If there was a loop, then we'll return code equals 1. And then I think we can just add the return codes together. But let's try this. Spawn task, put it in the background. This is going to be too many tasks to spawn. Let's try this. Let's just do this. Then we'll call wait immediately after and make sure we can do what we want here. So code equals $? If code equals 1, then num loops ++ fee. So we're echoing into a background task, but we're only doing one at a time, and we're going to do this against the example input. Okay. So every single one thought it was puzzle 1. And I think this is actually, I think there's a bash frequently asked question about this exact issue. Like this exact thing. Let me go look at chat. Let me take a break from this. Oof. This is actually nice learning threading with bash. Oh, yeah. With the you've been working with the Python GIL. Yeah, the global interpreter lock. I know that term, and that's about it. Yeah, so, I mean, we're going to be learning it together because I haven't touched this stuff in a long time. Spawn 1 row at a time? Probably. I'll probably just come up with some sort of arbitrary limit. And rows probably makes the most sense. A programmer has a problem. He thought to himself, I know, I'll solve this with threads. And then, yeah, and then, exactly. You nailed it. You absolutely nailed it. Increment current puzzle. Oh. Okay, yeah, I'm stupid. What do y'all want from me? Thank you, though. And this should actually happen right before we spawn a new one. I'll set this to 0. Cool. Total loops is 0. So this wait did not exactly work how I wanted to. Can't wait get the exit code? Return the status of the last ID. Fails if the ID is invalid or an invalid option if. I thought wait gives you the status code of the last one, right? Am I crazy? I really thought that was the case. Let me do some testing here. Echo returning ret. Let's just make sure that this logic works how I expect it. Yeah, so this one should be returning 1. And wait. Echo. Wait says code. Yeah, so wait is just not returning the code that this does, that I thought it would. Can I do this? What is the PID equals this? And I can do wait PID. There we go. That works. I have to specifically wait for the PID. That's less than ideal. That is absolutely less than ideal. And how are we gonna? I mean, we're basically. There's probably an easier way to do this, but what we are doing now is basically like creating our own job and queue management system in Bash, which isn't the end of the world. It's just a lot. Let me think about this. I would be lazy and append co-coordinates to a file and then count the lines in the file rather than doing it in one thing. Yeah, you could totally do it that way. My issue is I don't want to spawn a million tasks in the background because I don't know how well that'll work. So I want to limit the maximum concurrency of background jobs. And I don't think that'll do anything. It's working, but it's not doing anything any faster. I'm putting it in the background, but then immediately calling wait. So I'm effectively not even... I'm putting one thing in the background and then waiting for it to finish. So it's not running any faster than the original solution. I need to put a whole bunch in the background and then append their PIDs to like a list. So let me do some checking on wait. Wait, I think, what did it say for a list of them? If n is supplied, waits for a single job from the list of IDs, or if no IDs are supplied, for the next job to complete and return its exit status. I think... Yeah, what I don't understand is why do I not get the code if there's no ID specified. That seems problematic. Yeah, why do I not get the code? What I think I can do, though, I can do this. PIDs plus equal. So we'll add this to an array of PIDs, and then we can wait for all PIDs in that list, which will just be 1 in this example. So that works. Now we have to just append a whole bunch, and then we can do a wait here. If let's do this. Let's do this. If len equals PIDs, we'll get the length of how many pins we have stored up. If len is greater than 10, let's just do 10 at a time, then we will stop here and we will wait for one of them to finish. Any one of them, it doesn't matter which one we wait for. We will wait for one to finish, and then we will go on and we'll spawn another task, and we'll just keep going through this loop. Then when we break out of this loop, we will have to run this exact logic again to drain the rest of the PIDs that are there. So we'll have to say, we have to remove it from the array too. Oh, that sucks. How do you remove it when you're done? Oh, I know how to do it. I know how to do it very easily. This will be an associative array. Oh, yeah. Oh, yeah, we're on to something. We are on to something. The PID will go here because the PID will be some unique identifier, and we'll set this equal to anything because it's currently running. And then we will wait for all of the PIDs here. And then when any one of them finishes, we won't know which one it was. Yeah, how do you know which one it was? How do you know which one is finished? Oh my god. Okay, so we need a -p argument. -n options while it waits for a single job from the list of IDs. Okay, okay. Wow, okay. -n, -p ID. Oh my god. Okay. Let's do this. This is going to be bad. Sorry, guys. This is way more scuff than I realized. Cool. Okay. So we should have the ID of the one that finished. Yes. Okay. This is going to sound weird. This code right here takes a list of PIDs. We give it a giant list of PIDs that we have outstanding. -n means only wait for one of them to finish. We don't have to wait for the whole list. Just any single one of those PIDs needs to finish executing. And then we store the PID in this variable called ID. So we get the exit code. We get the ID. Now that we have the ID, we can unset PID's ID. I think I need $. We will unset that. So now we take it out of the array. Okay. This is going to work. This is going to work. Oh my god, this is going to work. Drain the rest of the PIDs. So we need to go while there's still stuff in PIDs. So while PIDs is greater than 0, while there are still outstanding PIDs, we will wait on them and then we will get everything from them. So we're going to run the exact same code here. We could put this in a function, but for now I don't really care. Take this. There we go. Oof, That was a lot. Thank you for bearing with me. But if this is... Oh, I wrote wild then. Do. If this works how I think it should... Total loop 6. And we did 10 at a time there. Boy. This is wild. And we are abusing exit codes to transmit data. Oh, boy, that's so funny. That is so funny what we're doing here. This is going to be just so much ridiculous output. So what I'm going to do here is we're going to get rid of some of these lines. So we're not flooding the output with stuff every time. Okay. And now we're going to find that thing where we say testing puzzle. We're going to get rid of the dash n here. There we go. So now we just have this. So we'll at least know roughly what puzzles we're on. And this is going to run 10 at a time. We could probably do more, but let's start with 10 at a time. Wow. I had to write a whole little job management thing in Bash. How beautiful. Okay. That is significantly faster. That is significantly faster. Oh my god. Like, I would be okay letting this run. That's super neat. Yo, thank you. I appreciate it because, oh my god, that took a lot of my skills to be able to do. If len is greater than 10, let's do this. Concurrency. This is how many threads will be used for concurrency. So let's make this, let's do 50. Let's do 50 at a time. There we go. Ha! Look at that. You can kind of see it batches up. Oh, wow. This is so much faster. I'm going to wait till I hear my computer start like kicking on the fans. Look, we're already at 1,000. Now, do you think we could push this much further? Should I stop it and try like a way higher concurrency? Or is this good enough? Just let this roll. I feel like we should just let this roll because we're already 2,000 out of 16. 1 out of 8. Not bad. It kind of seems maxed out. I agree. I'm okay with just letting this go. We're already about a quarter of the way there, so whew. Wow. So how's everyone doing tonight? Oh man. How many cores do you have? This shouldn't be a weight heavy task. Having more processed cores probably be counterproductive. It might be. It's true. How many cores do I have? I don't even know. This is running on an M1 Mac Studio, but it's like the M1 Ultra, I think. So like very beefy. Yeah, all the cores are maxed out. So, yeah, it's being crushed right now. Man, Bash is not the right tool for the job. Although, was the top CPU OBS? Okay, the top on CPU is OBS right now. So, I mean, like, whatever. That's frustrating. Listen, it's doing great, guys. We're almost halfway there. Look, we are 8,000 of the way there. Ben, that's like 16 standard trips. I mean, we're doing pretty good here. Maxing out your PC with Bash is funny. Listen, it's more likely than you think. I really was under the assumption that I would get more than day 6 today. I was like, oh, day 6 should be easy. Maybe we'll get 7, possibly even day 9. I've been streaming for 2 hours. And I only have now completed part 2, which we don't even know if it's completed. It could be wrong. Like, this could spit out an answer and I could be wrong. And if it's wrong, I don't know what to do. I'm a fan of the maxim that if brute force isn't working, you're not trying hard enough. Listen, I agree. I absolutely agree with that. Oh, man. Look at this. 75% of the way done. Come on. Who's complaining? Who's complaining here? We are crushing it with this. If it's wrong, check the scene path from part 1. I think so. I think so. YSAP doing it in Bash, and DYI Land doing it in Rockstar is what I'm here for. I have no idea what or who that is. But is that like a fellow creator, like doing some kind of crazy stuff that shouldn't be happening? Because if so, I'm interested, and I would love to take a look. There are 2 pretty beefy trims you can do to make this very fast. Yeah, I believe it. Absolutely, I believe it. Yes, I will post this code. In fact, you know what? I'll do that today. I'll go through and check this in on GitHub so people can at least have this code. I'll probably get rid of the real input. I think you're not supposed to share the real input, although does it matter? It's different for everyone. I'll double check that, make sure I can share what I can share. But yeah, I'll put the source code up. Let's see. Here we go. We're getting there. We're getting there. Only 500 left to check. I'm so scared. I'm so scared. 1516 is the final answer. Please do not share your inputs. Okay, yeah, I believe that you weren't supposed to share the inputs if I remember correctly, so I will just filter those out. I'll put the example one in there because that's what's on the website and everyone gets example to them, I think. That's probably fine. I'll double check, but I remember reading that somewhere. But at the very least, I will share the code because the code is super cool to see. 1516. You ready for this? We're going to see if this works. Oh, why is the YouTube chat showing up? That's interesting. Let's see. 1516. Let's go. Let's go. Oh my god. That's the right answer. You are 1 gold star closer to finding the chief historian. You have completed day 6. You can share this victory or return to your advent calendar. Oh, this is so exhausting, but it's so much fun. Ah, man. Let's go. Let's go. Thank you. Thank you, everyone. Oh, man. This is fun. Yeah, I don't have it in me to do another puzzle tonight. I am, after 2 hours, I'm taxed from that one. Nope, not time for day 7. I'll probably try and shoot for day 7 tomorrow and then see how far we can get. But after this, I'm a little bit wiped. For people asking, I hope you saw that day 1 is on my YouTube channel. So I uploaded that video. I went through and edited a little bit, cut out the parts where I'm just like chilling with chat. So yeah, feel free to check that out. That's awesome. Gonna go to sleep? Yeah, have a good night. Have a good night. But yeah, I remember reading, I don't remember if it was in the About page or not. Excuse me. There was something about sharing this and even streaming it. So I didn't want to stream today's puzzle. I don't want to do something that could possibly have people could cheat off of or whatever. Can I copy, redistribute? If you're posting a code repository somewhere, please don't include parts of Advent of Code like the puzzle text or your inputs. If you're making a website, please don't make it look like Advent of Code or name it something similar. Yeah, so this is one of those things where I was like, I probably shouldn't include the inputs at all. I can give an example of how to use it with your own inputs, but I think the code is safe to put up, but don't use any of the inputs. So yeah, that's how I interpreted that. Let's see. GG. Yep. What time tomorrow? If I do go live, it'll probably be around the same time. I think I started around 7 p.m. Eastern Standard Time, so probably shoot for some time around that. Let's see. Hope you kept the part where Eric revealed himself at the end. I did. So that's going to be in day 2, because on that day where I was streaming, I was doing day 1 and day 2. Eric jumped in at day 2, And I definitely left it in. That's what I'm putting at the beginning of the day 2 video where he reveals himself. It's great. It's so funny. So I'm going to leave the whole conversation there. I recorded the whole chat so I can put it up in the video. But yeah, that will be in day 2. Even though it was the same streaming session, it's going to be a separate video. Speaking of which, scroll a little further down that page. I swear if you're on this, I will lose my mind. Of course. Of course. Of course. You just wanted to have a reveal like Eric. You just wanted to have a reveal like oh, come on. No, this is awesome, dude. Oh my god, that's amazing. You're one of the community managers. That's so awesome. And you're one of the beta testers. That's amazing. Yo, thank you so much for jumping in the chat and hanging out then. That's amazing. Actually, then can I ask you, when it comes to sharing this on GitHub, I'm not going to put any of my real inputs on it. Can I put the example inputs? Or should I just stay away from that? The example input is what was taken from the website. I'm leaning towards probably not including them, even though it would be nice if people could run it against a really simple one. But I'm leaning towards not just putting my code and nothing else. And if you can't answer that question, I totally understand. I'll lean towards not putting the inputs in and just putting my own codes. Oh, but yeah, I appreciate it, dude. I'm glad. I'm so glad. I don't know why, I don't know how Eric found my streams or how you guys are finding my streams, but I appreciate it so much. I think probably not best to link to the puzzle. I will do that then. That is simple enough. I appreciate it. Thank you. Yeah. I'll just do my code, nothing else. And I'll have like a README, which will say how to run my code and where to get your inputs. And I'll link to this website. I think that makes the most sense. Cool. But yeah, I appreciate it. Oh my God. That's so awesome. I'm glad that I don't know. I'm glad there's a community around this and all the work that goes into it, because now I get to do fun puzzles and hang out with programmers and work on them. It's a ton of fun. This is just, it's cool. It's something to look forward to in these dreary winter months. So it's been a ton of fun. Yeah. Thank you everyone for tuning in. Let's see. Can you give me a roadmap to start in Bash? I'm taking Master and Comp Sci. No, I can't. I don't have a good roadmap. I can give you some resources, the Bash Wiki or the Bash FAQ. Bash Wiki, Bash FAQ. I'm just going to put these in chat for you. That's where I would go to start. That helped me a lot when I was learning. This was back in 2010, so it's been around for a while. I would start with those. In 2025, my goal is to make a Bash course. Now, don't let me scare you when I say the word course. It's not going to be like, oh, you sign up for this boot camp and give me $1,000. No. I'm probably going to make it a series of videos. I may put it behind a paywall. If I do, it'd be pretty cheap, but I may just put it up as YouTube videos. But long story short, I plan on doing a from zero to hero, multiple hours of here's how to learn Bash and how to get started with it. But that doesn't exist yet, so I can't point you to that. So instead, I'll just point you to those other resources. It's funny how Bash is used a lot in the enterprise, but is treated as the underdog. 100,000% it is, dude. People stand on the shoulders of giants, aka Bash, and then don't respect it. And I have no time for that. There's so many more from prior years to do. Endless content. Yes, you get it. It's the unlimited content glitch. Exactly. Oh man, that's why I had to pay it forward too. I made a PayPal donation to AOC and I got my little a plus badge from it, which was kind of cute. But yeah, I had to donate something because I was like, if I'm gonna make this into content, potentially make money off of it, I gotta donate because I'm definitely appreciative. Spoiler alert: I don't make a lot of money off of YouTube yet. I would like to, but yeah, I'm not that big of a creator, so you don't make much on ad revenue or anything like that. Ah, man. Let's see. Now do it in awk. Listen, there are probably ways to do these in awk. Awk is incredible, but it's I don't know how I would approach these problems in awk. I mean, you've seen the way I write Bash. I write it like I'm in C. I write it like I'm in a different programming language, so it does not work well. I shouldn't say that it works well, but you know what I'm trying to say. Bash to C+ convert. Listen, I don't want to convert Bash to anything. There was a project that people wanted me to check out that I think it was JavaScript to Bash. I forget. I think it's called Amber Lang. The language is called Amber, and it's some sort of ECMA or EMCA, whatever that term is, script. So it's similar like what JavaScript is, but it gets transpiled into Bash. I've never looked into it. Everyone has told me to look into it, but I'm scared because sometimes the bash is really good, but a lot of times what people consider bash is just like a mismatch of multiple different syntaxes throughout the decades, and it's just kind of a mess. But we'll see. Vim script, no thank you. No thank you. Check out some of the visualizations for AOC. I've been getting them as YouTube recommendations, but I've been trying to avoid them because I don't want to spoil any of the puzzles. But I've noticed some of the visualizers are for like years old puzzles, which I'm still going to do, and I don't want to spoil. But if you're talking about yours, because you're in my Discord, I will be looking at yours now that I've solved it myself and feel comfortable with it. And I will put these solutions up. In fact, I've decided, because I was like, oh, I could go through this code and kind of clean it up and make it nice. And I'm like, no. I'm going to upload exactly what I wrote on stream. That's it. Won't be accepting pull requests. Like, this is what I came up with on stream. If there's bugs, hey, there's bugs. Like, this is the code I wrote on stream. I figure that's the best way to do it. Some of the visualizations for today's puzzle hit me right in the nostalgia. Ooh, I'm excited for that. December 9th puzzles then. Is that the latest one that's up? Whoops. That's not what I want. What is the latest one? December 9th, yeah. Oh man, I'm only 3 puzzles behind. That's not bad. I'm so tempted to look at puzzle 7, but I don't. It'll take too much time. Because there's other stuff I want to do tonight. There's probably a one-liner in Perl. Absolutely. Bash with evals. I try my best to avoid it. I've used it in places. There are places where it makes sense. Please use Rust. Listen, if I were to write this in Rust, it would have been so much faster. I could have left it a single thread and it would have just churned through it. I probably could go through and quickly, well, I don't want to say quickly, but I could probably write this in Rust. Imagine if you use colors for tracking paths. I mean, these would all be so fun. No, I don't want to take pull requests. No. Because this code is like, here is the code I wrote on stream. If you watch my stream, you can go get that exact code. It might have bugs. It might have X. It might have Y. It might have Z. But this is the code you saw on stream. I would like to retain that with it. Let me ask real quick. I do have some stuff I want to do tonight, but I have some time. I have like 20, 30 minutes left. I have a decent amount of viewers. Do you want to see me rewrite this in Rust? Do people want to see that? Is there any interest in that? If not, I won't be offended. But is there any interest in me writing this in Rust? Because we can compare how fast it would be. I could probably go through and do part 1 and part 2 in Rust. Sure, Rust is nice. Yeah. Okay. I'm convinced. Let's make a new one called Rust Impl. Oh my god. Okay. 1. Yes. Thanks, Ben. I'd be interested in... Okay. We're going to do Rust. Oh boy. Here we go. Do I have other Rust projects on here? Please do. I don't. Switch to terminal. Thank you. I'm gonna grab... Yeah, let me do this real quick. Sorry, I'm gonna pull up something real quick. I know I'm not sharing anything. I'm gonna pull up a previous Rust project where I have a Rust format file that I like to use, and I'm just gonna clone this down because that's kind of how I like to start things. So share the terminal. Okay, all I've done so far is cargo new Rust impl. That's all I've done. So we will cd into Rust impl. We'll vim rust format.toml, and we'll put this in here. Max width of 80 and use small heuristics. This is how I like to format my code. So let's do a nice cargo build on this and let it compile for the first time. There we go. Cool. So now what can we do? Let me remember how to do anything in Rust because it's been a while. Source main. Yeah, cool. Let me think about how I want to approach this. Okay, we have example. Okay. Source main. Okay. Let me pull in some crates, actually. Cargo, add, anyhow. This is one of my favorite crates. It just allows me to do really, really basic error checking. Sounds like you're rusty with Rust. Clever. Let me tell you this. Context switching between Bash and Rust breaks my brain because the environments are so different. But I'll get back in the Rust mode. I write it a lot. I write it on a daily basis, so don't worry about it. I'm okay here. Let's see. If you're anything like me, first you do it wrong, then you listen to the compiler and it tells you how bad you are. Yes, I do. There are some times though where I like add lifetimes to a struct and then compile it and there's no warnings, and I'm like, no, the compiler must be wrong. There's no way I got these lifetimes right from the beginning. Like, those are scary. All right, so what we can do here is use anyhow results, and this just gives me a nice result type that I can return from my main method. So now I can just return okay. And this will allow me to do very easy error checking in Rust by just being able to put a question mark in my main method. So the first thing we need to do is we need to read the file. Let's just pull in fs, which is the fs library. I think it's fs read to string, and we need to read the file into the string. So let's say contents equal this. We do need to get arguments. How do we pull out environmental? Is it user? I'm gonna make up some syntax before I Google it. I think it's standard env, and I think you can do let args equals env args. I don't know. Let's go ahead and compile this and see what happens, because the chat says it. Compiler is my friend. 100%. This is absolutely true. Argument is missing. Oh, right. Yeah. Let's just make sure args is right. Yes. Okay. Args is right. So I think we can do env1. Print line. I think we can do args. Let's just see what I'm pulling in as an option of a string. Okay. Need file as arg1. Cool. All we're doing is we're pulling out, I can't use context because I have to pull it in. We're pulling out the first argument. So this program, instead of reading it from standard in, this program is going to read it as the first argument. That's just easier for me to write here. Okay, so now we have args. What happens when I run it? Cargo run -q example input. Cool, so it just found the argument. Perfect. So we'll call this file. We will read that file into contents. And now we should have, if we print the contents, we should have that exact, we should have the contents of that file. Now let's just format it nicely. We need a question mark here because this can return a result, because this operation could fail. Hey, look, we've read the file in, and we have a trailing new line because we use print line, which adds a new line, and the file already had a new line at the end of it. Cool. So now what we can do, let me remember how to do this. For line in contents dot lines. I think lines is a method. Print line. I think this is right. I just spelled it wrong. Yeah, lines. That's what I was picturing, but I just wrote it incorrectly. Hey, look at that. Now we're reading it line by line. Let's create our grid system here. So let mut grid equal a vec of a vec, and we won't set it equal to anything. So the compiler doesn't know what this type is. We're going to let it infer this type by us loading things into it. So let's comment that out for now because the compiler will yell at us. We have lines, and we want to split it on nothing. So for C, which is character, I think we can do line.split on nothing. I think this works. Don't quote me, but we're going to find out. Empty character literal. Yeah, because it's a character literal, it has to be character. I think I give it a string. There we go. So now we are looping over it character by character. We may have to do some trimming here. What I mean by trimming is, yeah, we might have some empty lines that are being processed, and we don't want that. So I think, does it have trim? I think it has trim methods. There we go. Still looks wrong, but we'll deal with it when we deal with it, right? So reading the file in, let mut width equal 0, let mut height equal 0. The grid is a vec of a vec. In here, we will create a new thing. We'll call this row. And then we will do grid dot push row. Cool. And then we'll do row dot push C. And then we'll print line whatever the grid is. So this should be the entire two-dimensional array. You see how nice it is to have a language with two-dimensional arrays? So have I lost anyone yet, or are people kind of following what's going on? I realize I'm moving quickly, but hopefully I'm kind of doing a decent job explaining. So yeah, we have these empty things, and that's not great. Why are we having empty characters? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, having an empty character at the top and the bottom is not ideal. Where are those coming from? I feel like trim should trim them all off, right? Am I crazy? Let's see. Lost me when you opened your terminal for the first time. I love that. That's amazing. Can you use line.chars? Oh, yeah. That is a method, isn't it? I think you can. Yeah. I think you're right. Thank you. I forgot that was a thing. Oh my god, that's so much nicer. That's so much nicer. Now they're actually characters instead of just strings. Yes, thank you. I can use that. And I am using that, and it's beautiful. So, now that we have these set, we can do width equals... let's do height first. Height equals grid.length, which is .len, and width equals grid spot 0.length. This will blow an assertion if there isn't a 0th spot, but we're going to assume the input is good, so that should be there. So now we can print, let's see, puzzle height equals this, height. Width. Okay. Cool. We're good. What did part 1 do? I literally don't remember what the puzzle was. She walked around and we had to figure out how many distinct places she visited before she left the puzzle. Cool. That's what she did. So we need to make her walk around. Let me look at the bash one so I can remember exactly how I accomplished that. Oh, I accomplished it. Ooh, wow. I haven't looked at this code in like an hour. Oh man, I don't know what's going on. Oh yeah, this is where we try to move her in a direction. Okay. So we can do some cool stuff here. We can make an enum. How nice is that? Look at this, and we don't have to check for an unknown one because Rust does that for us, which is so awesome. Rust is such a great language. I love it so much. Oh, while we're here, we should also find out where the guard X and Y is. These are the guard coordinates. If C equals this character, then we know it's the guard. So then we can set the guard coordinates to the X and Y of where we are. But we don't have the X and Y because we haven't been counting it. That's annoying. Probably a better way to do this, but here we are. There we go. So now we should have the guard coordinates at that. Let's go ahead and print those. Guard coords equals, and there's going to be some ways I can clean this up. Okay. Guard coords at 4 and 6. Is that right? She is 0, 1, 2, 3, 4. So she's 4 down, and then 0, 1, 2, 3, 4, 5, 6. Yep, that's exactly where she is. Let's do some. What are enums again? I forgot. Enumerate. Yeah, basically that's what they are. So this thing is direction is an enumeration, so it has these 4 constants. You can just sort of treat them like things. I could say like let direction equal, this is not valid code because I'm not in a function, but I could say like let direction equals direction : up, and then I can like check down here if direction equal direction down. The beauty of this is they're not like a string or some sort of underlying data structure. They are just this, I think Rust calls them zero cost abstractions. They just exist in the code, but they can get compiled out or compiled into a really optimized way. So they're just super nice way of that. Let's see. Please do a video about moving stuff around in Vim. How do you copy and paste indent so fast? I will do that. I will do that. I'll give you the quick lesson. Shift V. I'm moving up and down. I'm highlighting lines. Copy with Y. Y is for yank. Delete with D. D is for delete. And then hit P and just paste it back. So that's the quick, super fast version. No, sorry, I was saying using for Y comma line in contents trim lines enumerate. Oh, I see. Yes, you're right. Yes, you're right. That is so much faster. Thank you. That is definitely cleaner than doing it this way. So for anyone paying attention, I can do the enumerate method on this because this returns something that's iterable. So when you have an iterator, you can call .enumerate on it, and now it returns 2 things: the number, which was Y, and the line. I think I have the order correctly. I think it returns the number first and then the data. I think it does number first and then the data. I could have it backwards, but I think this is right, and I think that's what you wrote in your example. So if that's correct, then I can just do this. Oh, right. So because I used enumerate, they returned a U, an unsigned integer, and I'm using -1 here as a placeholder. Let me teach you a quick lesson about Rust, okay? This would be called a sentinel value, -1, meaning this is a special value that means it's not found, and Rust doesn't like when you do this. So instead, what we are going to do is we're going to set this to none, which is an option type, and then down here, we're going to set this to sum, meaning that we found a tuple of what we were looking for. Then, down here, we can do something really beautiful. Guard coords equal guard coords dot unwrap. Uh-oh, could not find guard. So this is really cool. I think this will work. Let me just double check that I'm not making up syntax. Unwrap doesn't take a string. My bad. Unwrap doesn't take a string. If you want to use the function that takes a string, it's expect. So I typed the name in wrong. Oh, I did. Guards coord, yeah, guard coords. There we go. I just had the wrong variable name in there. So now we run it. We still get an error. Cool. Oh right, I wanna unwrap it to not be an option. That's what I want. So I don't want to mutate it. I want to do this. I want to create a new variable. I want to shadow it. Need let again. Yes, exactly. Yeah, I just realized that. Cool. So this is the very rusty way of doing it, where we set this thing equal to none, and then if we found it, we set it equal to sum. In fact, we could even like assert here that guard coords dot is none. And that's our way of saying like, oh, hey, we only ever want to find one guard in the puzzle. If we find more than one, something's wrong. So now down here, we can ensure that in 2 things in this line. We ensure that we did find guard coordinates, and now we made this new variable with the same name, so we shadowed the previous variable, but this is just set to the tuple of coordinates that we found, not the option anymore. So we can deal with it just with, you'll see how I deal with it later. But yes. So now, yeah, we have some warnings because I have unused variables. That's okay, but we can see puzzle height equals 10, puzzle width equals 10, and we know exactly where the guard is. Hey, that is so awesome, right? So let me pull up part 1 again. I just want to remind myself of my actual flow. What did I do once we have all that stuff? We kept track of what we've seen. I'll worry about that later. I'll add that later. We just go into a loop of trying to move her. Okay, so let's do that. So we're going to try and move her. Let's go into a loop. While true. Actually, we're in Rust. Loop. We can just use the loop construct. There is just a construct in Rust called loop. Very nice. So, try try to move her and see what happens. So we know the guard coords, and we want to have, let's say, let new coords equals something. Oh, this is so cool. This is so cool. Oh my god, I love Rust. I really do love Rust. Like, I love Bash because it's so niche, but I love Rust because it's so clean. You ready for this? Let new coords equals match direction. So we haven't done this. We haven't initialized her direction. We should do that. Why did I do this? What am I thinking here? What is this? What is this? What am I doing? Sorry. We can get rid of those mutts. We don't need them to be mud. We just set them here, and then we're fine. Now I totally forgot what I was doing. Oh, we need to initialize her direction, right? So she starts going up. We know that. So her direction is set to up. We are going to be able to modify this, though. So we are going to figure out her new coordinates by looking at her current direction. If it is direction up, then her new coordinates should be her old coordinates with her y set to a smaller number. This is an interesting thing. Let me think about this. Because I'm using the enumerate function, the coordinates will be unsized integers. And then if we subtract from it, we're not going to get a negative number. We're going to get a very, very large positive number. So I think we're going to need to use a Rust function. I believe Rust has a function that lets you add or subtract from a number, but check to see if there would be an overflow in the process. Because this is low-level stuff. Your CPU is what can determine that by setting the flag for that. So I think we'll have to do that. This might not be as clean as I want it to be, but let me mess with this. Yeah, because it would be guard coords dot 0 and guard coords dot 1. And this one's the y one, and we want her to move up, so we have to subtract 1 from it. I'm going to write this like this for now, but this will have an issue with overflowing, so we will have to use checked variants of these commands. Sounds confusing, but I'll explain it when I actually bump into it. So now I've just copied and pasted that 4 times. Direction down. If we're going down, then the y value goes up. If we're going left, then the y value goes down. And if we're going right, then the y value goes, or sorry, the x value goes up. I don't remember what I said. Ignore what I said. Look at what I wrote. So yeah, I think we'll have to use some sort of checked variant because we're gonna get into a heap of trouble when it overflows. But let's worry about that when we get to it. Print line, trying to move her from 2. Cool. This is debug print notation in case anyone's wondering. I can't just print a tuple directly as a string, so I have to print it, I have to debug format it, and that's how I do it. Guard coords, new coords. Cool. And then, yeah, we just seem to do this in a loop. And let's just run this. And it's going to be wild. We're going to cargo format. We're going to format the code. Oh, look, there's a syntax error. Yes, because we did let here. Cool. Cargo run. Okay, and we never actually set it. Right. Cool. So this is a lot cleaner. Yeah. So I cargo formatted the code. That's why it looks slightly different now. So now we tried to move her into this direction. We need to check at the new coordinates if there's going to be some sort of collision. So the grid is in YX format. So we'll have to check current character equals grid Y and X. So Y would be new coords dot 1, comma, nope, new coords dot 2 because we're using a 2-dimensional array. So we'll grab that from it. What's going to happen is this is going to crash eventually once we get out of bounds, and that's when we'll deal with it. Let's just move her here. And the way we move her is by saying guard coords equals new coords. I think I can just do that right. Oh yeah, unreachable statement because it's an infinite while loop. Oh, I did dot 1 and 2. Yeah, I'm stupid. Dot 1 and dot 0. Yeah, so this would be X. Good night. Got to good. I think you mean gotta go. Keep up with the shell and systems programming stuff. Yo, appreciate it. Yeah, have a good night. Have a good night. And yeah, I'm gonna be finishing up soon here. I'll probably just do part 1 of this day because I'm losing interest. Cannot assign twice to immutable variable. What does that mean? That's what that means. Cool. Here we go. So we did try to move her. We moved her in all these directions. Attempt to subtract with overflow. Yeah, so there's a way to do this. I think it's like, does anyone remember off the top of their head? I guess it'd be aneurysm who would know. Is it check sub and check mul and checked? I think it's like check sub, checked add. I think it's just a function. Let's just make up some syntax and see if it works. Don't forget about awk. It's fast. Listen, man, I believe you. I think it's checked. I think you do this. Checked sub 1. I think it's that, and that returns a result or something. Yeah, it returns an option. Okay, cool. Okay, yeah, it's check sub and checked add. And that will return an option. If it's some, then it was valid. If it's none, then you created an overflow. The nice thing is here, if we create an overflow, then we know that we're out of bounds. So the beautiful thing here is we move this. We move this into a function, and then we can return early from the function. Function get new coords. I don't know. Who cares? Coords is a tuple of a U something. What do you think it is? A U64? A U size. It's a U size. That's what it is. Which probably is a U64 on my machine, but that's neither here nor there. Option of a U size. Yeah, that's what it returns. So the beautiful thing we can do here now is we want to take the coordinates and the direction. No, we're returning a U size, and let's take a pointer to this. Okay, I'm gonna cargo format real quick just so it looks nicer. Okay, so we have a function called get new coords. It takes two things: a pointer, a reference of the original coordinates, and a reference of the direction we want to move in. So now we can just do this. There we go. Cool. And now, because we're using check sub, we can just put a question mark here. Checked add. And we just put a question mark here. So if you're confused as to what's going on, instead of subtracting them using the subtraction, like the minus sign or the plus sign, we're using these functions because these functions can fail. And the way they fail is if you're going to create an overflow scenario. And the beauty of that is that the way they fail is they return an option with either none or some. So we can just forward that option through this. So we can just use the question marks here. Now, if this function returns none, then we know that she tried to walk out of bounds. And then we can basically just break out there. Let me just not worry about this right now. Try to move her. Let new coords equals get new coords, and it takes the original guard coords and the original direction, and then we should match on it. So we'll do let new coords equals match this, and if this returns some, then we just save it to that variable. If it returns none, then we will print line she walked away, lol, because we're out of bounds, and then we will break from the loop. That's what we will do here. So what happens here? We expected an option. Oh, okay, right, yep. This whole function expected an option, so what we can do here is we can just do boot some here and some here. There we go. Cool. So now we can see because she tried to walk out of bounds, she walked away. Now, she didn't actually walk out of bounds. We just don't have collision detection, so she just kind of left as quickly as she could. So we need to actually handle collision with her, which is super easy. So now that we're trying to move her there, we know that both of these are in bounds. Let's see. If we can match on C. If it's a period, then we know that she's moving in a way she can move. If it's a pound sign, then we know that she hit an obstacle. And if it's anything else, then we panic because WTF is this? Because we shouldn't expect anything else. There we go. Rust is so beautiful when it's written right. Oh my god, I really do love this language. So, if it's a period, then we want to try and move her there. And the way we do that is by swapping the two coordinates. We don't try to move her there, we do move her there. So grid new coords dot 1 new coords dot 0 equals her character. And then we have the guard coords. These were the original ones. They get set equal to a period. And then we do guard coords equals new coords. So this should handle moving her. And then now we need to handle collision. So if there's collision, we need to rotate her. And the way we rotate her is we just change her direction. Direction equals match direction. And look how beautiful this code is going to be. You ready for this? This is my favorite thing. If she is facing up, then she will face right. So we're just rotating her clockwise. That's all we're going to do with these. We're going to handle all 4 possible situations and point to what her old and new one should be. So if she was facing right, then she should be facing down. If she was facing down, then she should be facing left. If she was facing left, then she should be facing up. Let's see. And then what happened here is we didn't do any bounds checking because we only checked the bounds in one direction. That's what we did. We only checked if she walked away going out the bottom or the right of the puzzle. We didn't check to the left or the top of the puzzle. So here's what we can do. Actually, we should put it in new coords because new coords checked if it was, no, we shouldn't. We're going to check it down here. So basically, we only checked if there was an overflow. And if there was an overflow, sorry, let me rephrase this. If we check if there's an overflow, that means she went to the left or she went up, which would have been in the negative direction. We need to check if she went too far. So if new coords dot 0, which is the x, is greater than or equal to the width, or new coords dot 1 is greater than or equal to the height, then print line, she also walked away, LOL. Break. There we go. So that's it. Now we're moving. We are moving. Now we need to keep track of every place she has ever visited. And the way we do that is we create another one of these. So we have a grid. We'll call this the scene grid. How many places we have seen. So scene row, scene grid dot push scene row, and then we will say scene row dot push false. Yeah, this is fine. So we're making a 2-dimensional array, associative array, where we will associate an x and y coordinate with a Boolean value. We'll default all of them to be false. And then whenever she moves to a new coordinate, we will set it equal to true. So if we got here, she was able to move to new coordinates, then scene grid, guard coords dot 1, guard coords dot 0 equals true. So now we keep track of all the places she's seen. We have that. Now we just get the length of scene down here, and we're done. Scene blank distinct places. Scene grid dot len. There we go. Scene 10 distinct places. Was that right? Where's part 1? The guard will visit 41 distinct places. So we have this wrong. Hash set of you could totally do that. Yep. Yes, 41 is correct for the what I should be seeing, and I'm seeing 10. So that's correct. Incorrect. You could definitely do a hash set. Hash set's a cool thing for anyone watching. You can just put things in there and it will automatically deduplicate it for you. So the way that I'm using Booleans here for this two-dimensional grid is totally just doing what a hash set could do. So let me go ahead and just use a hash set. Is it standard collections? I think that's where a hash set. I think it's standard collections, right? This is how I program. I don't really even like look stuff up. I just kind of wing it. Scene row. Let's get rid of all this scene stuff. Let's do scene equals hash set new. And then we don't even need to give it an explicit type because we can just create it here. Scene dot insert. I think it's insert. It doesn't matter which order we do these in as long as the order is consistent. I think we can just do that. And then we can just call scene on this. You're right. Okay, so what was happening with the old thing? I called the len on it, which of course the len was 10 because it was a 10 by 10 grid. I needed to actually iterate over there and find all of the ones that were true. Instead, thank you aneurysm, you just use an hash. Thank you aneurysm, what a wild sentence. We just use a hash set. So a hash set, I'll show people what it looks like at the end. If I were to print that hash set out, pretty print it, put the pound sign in that debug notation, you get pretty printing, it will look like all the places that I visited. So it just keeps track of everyone I placed. And if it gets inserted in there multiple times, it gets deduplicated automatically because it's a set. The underlying data structure will handle that for you. So yeah, good call. That was the right way to do it. So let me cargo format this. Let me go here. Let me remove that. Cargo Clippy, make sure our code is good. There are two things that are not good. Unneeded return statement, right. I don't need this. Implicit return if you omit the semicolon as the last line. And we're good. So let's go ahead and run this. We should see 41 distinct places. Awesome. Let's go ahead and give it the real input. And if we look at this, your puzzle answer was 4433. So let's go ahead and assert that this is the case. 4432. 4432. What is happening there? Why am I off by 1? I'm going to be honest. I did not expect that to happen. Why am I off by 1? That is wild. Oh, I know exactly why I'm off by 1. You got it. Starting place. In the original bash code, yeah, I'm off by 1 because I didn't include the starting place. In the original bash code, look at this. I keep track of her starting place right when I create the data structure. I think we got lucky in the example because I think she walked over the starting place, so we recorded it the next time. I don't think. I know exactly that's what happened. So here, we should keep track of the coordinates immediately. That's what happened. Oh, boy. Yep. That's exactly what's going on. It was a starting position, 4433. If I pull up the original page, 4433. There we go. That's it. I would love to do part 2 of this problem, but I don't want to. I'm burned out. I'm tired. I've been streaming for almost 3 hours, so I'm going to call it a night here. It would be fun to see how fast it would go. Maybe I'll do it a different day, but yeah, I'm going to call it here. But there you go. There's the Rust solution. Like I said, I'll put this code up and I will filter out all of the text inputs. I'll probably just put a git ignore for star.text. Yeah. Is there anything fancy about how to visualize it in Rust? Wouldn't be any fancier than how we did in Bash. You'd have to create some sort of function to print the two-dimensional grid and then clear the screen. Clearing the screen in Rust, I mean, pull in a crate like console that can do it, or just omit the code, the ANSI escape code for clearing the screen. That would probably be the way to do it. So yeah, I'm not gonna do a visualization here. If I wanted to, I could use like Macro Quad, which is like a game engine, and I could do like a really fun visualization of it. maybe later, maybe if I hadn't been doing this for the last 3 hours, I would do it. But yeah, pretty fun stuff. So yeah, hopefully people enjoyed that. As you can see, I think the code ends up being way cleaner, and I already knew kind of how to do the algorithm, so it wasn't too bad. But yeah, hopefully that was enjoyable to watch. So yeah, I do Bash, but I also do Rust. I really, really like Rust. It's a really good language. So let's see. That was super fun to watch. Thanks. That was super fun. Yeah, yo, I appreciate it. I'm glad you guys liked it. That was awesome. Thank you for streaming and all you do for the general community. Sharing knowledge makes us all better. Yo, I appreciate it. What a nice compliment. I appreciate hearing that. I tend to use the functional style a lot more. Dot map into for parsing and the like. Yes, I think that's good, and I should spend more time learning how to do this. As you can see, I kind of approach it very like procedurally. I approach it very top down, solve the problem, and then if this were something I were gonna put into production or whatever, I would go through and find ways to clean it up. But my code tends to be this way. It's kind of overly verbose and very parsing things step by step. But I like it because when I go and review this 5 years later, I should have at least some idea of what's going on. But that's the goal, at least. At least that's how I cope with how I code. Oh, man. Now I got to go find my bug. Hey, I wish you luck. I wish you luck. I will... You're in my Discord. I'll go... I'll upload this code today. Soon, and I'll put it in my Discord when I actually upload the code. But yeah, thank you everyone for tuning in. Hopefully this was fun. Hopefully you all learned something. But yeah, I appreciate it. Thank you all for stopping by. And actually, I guess question for people in here. I like to upload these as separate things. So like I have Advent of Code Day 1 where I go over part 1 and part 2. I'm going to make a new video, Advent of Code Day 2, where I go over part 1, part 2, and Eric jumping into my stream and talking to him. Do you think I should leave this Rust portion at the end as sort of like a bonus? I'm probably not going to upload it as its own episode, but I would probably upload it in the video as like a bonus. Like, hey, here's another way you could do it in Rust. I think I'll just leave it in the same video, unless you think other videos make sense. I don't know. I'm still getting used to this content creation stuff. Yeah, when I look at puzzles I solved a couple years ago, I sometimes have no idea what the code is doing. Yeah, I completely understand that. Absolutely. Yeah, same video makes sense. I think so too. If I was trying to maximize engagement, I'd probably just do 2 videos, but I don't care about that. So yeah, thank you everyone. Thank you for tuning in. This was super fun. Appreciate all you dropping by. Like I said, I probably will stream tomorrow around 7 p.m. Eastern Standard Time. No guarantees though, but if I do stream, it's going to be at that time. So, yep. Yeah, thank you everyone, and I'm going to call it here. So, yeah, hopefully that was fun. Have a good night. See you everyone. Take care.